Hello, everyone. I'm Bhumika Mohan, studying in Sri Venkateshwara College of Engineering, Bangalore. Today, I'm going to talk about bisection method and Lagrange's inverse interpolation formula. The contents of this video are bisection method. Under bisection method, we are going to talk about definition, method, advantages and disadvantages, and lastly, example. Then we are going to talk about Lagrange's inverse interpolation method, and under that, we are going to discuss definition, formula, and example. Bisection method. The bisection method is a straightforward method used to find numerical solutions of an equation with one unknown variable. This method is a root finding method that applies to any continuous functions with two known values of opposite signs. It is a very simple but cumbersome method. The interval defined by these two values is bisected, and a subinterval in which the function changes sign is selected. This subinterval must contain the root. These two steps are repeatedly executed until the root is in the form of the required precision level. This method is also called as interval halving method, the binary method, or the dichotomy method. The explanation of bisection method. Let f be a continuous function defined on an interval a to b where f of a and f of b have opposite signs. Bisection method is applicable for solving equation f of x equal to 0 for a real variable x. At each step, the interval is divided in two parts or halves by computing the midpoint c equals a plus b by 2 and the value of f of c at that point. Unless the root is c, there are two possibilities. F of a and f of c have opposite signs and bracket a root. Or f of c and f of b have opposite signs and bracket a root. One of the subintervals is chosen as the new interval to be used in the next step. This process is carried out again and again until the interval is sufficiently small. If f of a and f of c have opposite signs, then the value of b is replaced by c. If f of b and f of c have opposite signs, then the value of a is replaced by c. In the case that f of c equal to 0, c will be taken as the solution and the process stops. Advantages and disadvantages of bisection method. Advantages. Convergence is guaranteed. Error can be controlled. Simple and easy to program. Disadvantages. A slow linear rate of convergence. Cannot find the rate of some equations. If one of the cases is closer to the root, it will still take a larger number of iterations. For example, question. Let's determine the root of the equation f of x equal to x cube minus x minus 2 for x belongs to 1, 2. Solution. Given f of x equal to x cube minus x minus 2 for x belong to 1, 2, take a equal to 1, b equal to 2. F of 1 equals 1 cube minus 1 minus 2 equal to minus 2. F of 2 equals 23, 2 cube minus 2 equals 4. As the function is continuous, a root must lie within 1, 2. First iteration, a1 equal to 1, b1 equal to 2, c1 equals to 2 plus 1 by 2 equals 1.5. Hence, the function value at midpoint is f of c1 equals 1.5 cube minus 1.5 minus 2 equals minus 0.125. As f of c gives a negative value, the value of a is replaced by c. The iterations are concisely summarized into a table like first iteration a of an is taken as 1, bn is taken as 2, cn is taken as 1.5 and f of cn is given by minus 0.125. Second iteration, an is 1.5, bn is 1.2, cn is 1.75 and f of cn is given by 1.6093750. Third iteration, an is 1.5, bn is 1.75, cn is 1.625, f of cn is given by 0.6660156. So on till the fifth iteration is given by an 1.52136233, bn is given by 1.5214233, cn is given by 1.5213928, f of cn is given by 0.0000780. From the table, it can point it out that after 13 iterations, it becomes apparent that the function converges to 1.521, which is concluded as the root of the polynomial. Lagrange's inverse interpolation. What is inverse interpolation? Given x0, y0, x1, y1 till xn, yn, find the value of x at a value of y that is not given. Interpolation, Lagrange's formula. We have been finding the value of y corresponding to a certain value of x from a given set of values of x and y by using the Lagrange formula given by yg equals y0 into L0 plus y1 into L1 plus y2 into L2 plus so on till yn minus 1 to Ln minus 1, where L0 equals xg minus x1 into xg minus x2 till xg minus xn minus 1 by x0 minus x1, x0 minus x2, so on till multiplied by x0 minus xn minus 1. L1 equals xg minus x0, xg minus x2, so on till xg minus xn minus 1 divided by x1 minus x0 into x1 minus x2, so on till x1 minus xn minus 1. L2 equals xg minus x0, xg minus x1, so on till xg minus xn minus 1 divided by x2 minus x0 into x2 minus x1 till x2 minus xn minus 1. So on till Ln minus 1 equals xg minus x0, xg minus x1 till xg minus xn minus 2 divided by xn minus 1 in minus x0 into xn minus 1 minus x1, so on till xn minus 1 minus xn minus 2. Inverse interpolation Lagrange formula. On the other hand, the process of estimating the value of x for a value of y is called inverse interpolation. When the values of y are unequally spaced, Lagrange's method is used. And when the values of y are equally spaced, Newton's forward difference formula or iterative method can be used. Lagrange's formula for inverse interpolation is used when we are required to find the value of x corresponding to a certain value of y from a given set of values of x and y. The formula is as follows. Xg is equals x0 into L0 plus x1 into L1 plus x2 into L2 plus so on till plus xn minus 1 into Ln minus 1. L0 equals where L0 equals yg minus y1 into yg minus y2 into so on until yg minus yn minus 1 divided by y0 minus y1 into y0 minus y2 so on till y0 minus yn minus 1. L1 equals yg minus y0, yg minus y2, so on till yg minus yn minus 1 divided by y1 minus y0 into y1 minus y2 into so on till y1 minus yn minus 1. L2 equals yg minus y0, yg minus y1, so on till yg minus yn minus 1 divided by y2 minus y0 into y2 minus y1 into so on till y2 minus yn minus 1. So on till Ln minus 1 equals yg minus y0, yg minus y1, so on till yg minus yn minus 2 divided by yn minus 1 minus y0 into yn minus 1 minus y0, y1, so on till yn minus 1 minus yn minus 2. For example, find solution using Lagrange's inverse interpolation formula. The given values of x are 168, 120, 72, 63. For the values of f of x, 3, 7, 9, 10. For f of x equal to 6, find f of 2. Solution. X values are 168, 120, 72, 163, 72 and 63, where the values of y are 3, 7, 9, 10. Lagrange's inverse interpolating polynomial. The value of y at you want to find Pn of y is y equals 6. Lagrange's inverse interpolation formula is as follows. So when we calculate x of 6, the formula becomes 6 minus 7 into 6 minus 9 into 6 minus 10 by 3 minus 7 into 3 minus 9 into 3 minus 10 into 168 plus 6 minus 3 into 6 minus 9 into 6 minus 10 by 7 minus 3 into 7 minus 9 into 7 minus 10 into 120 plus 6 minus 3 into 6 minus 7 into 6 minus 10 by 9 minus 3 into 9 minus 7 into 9 minus 10 into 72 plus 6 minus 3 into 6 minus 7 into 6 minus 9 by 10 minus 3 into 10 minus 7 into 10 minus 9 into 63. X of 6 becomes minus 1 into minus 3 into minus 4 by minus 4 into minus 6 into minus 7 into 168 plus 3 into minus 3 into minus 4 by 4 into minus 2 into minus 3 into 120 plus 3 into minus 1 into minus 4 by 6 into 2 into minus 1 into 72 plus 3 into minus 1 into minus 3 by 7 into 3 into 1 into 63. X of 6 becomes 0.0714 into 168 in plus 1.5 into 120 plus minus 1 into 72 plus 0.4286 into 63, which x of 6 becomes 147. So the solution of the polynomial at point 6 is x of 6 equals 147. Thank you.